Here we go. Next up, geometric sequences. Now we've looked at arithmetic sequences, and now we're going to look at geometric. Geometric, instead of having a common difference, in this case, we're going to have a common ratio. So what's happening here is, now if you look at the example that they're setting up right here, they're doing this term multiplied to get the next term, and then this one multiplied by 3 to get the next term. But what happens is we want to set this up as a common ratio. So to figure out, so we have 2, 6, 18, 54. This is a geometric sequence. It's telling us that. But if I were to look at this and I didn't know that, I would take 6 and divide it by 2. And then I take the next 2 in the sequence, 18 divided by 6, it gives me 3. And then 54 divided by 18 equals 3. That is how we figured out this common ratio, which is what we'll call it. Now, we have a general form. Once we're able to figure it out, the geometric sequence, we have a general form of un equals u1 times r n minus 1. R is your common ratio. So this is r, which I'm pretty sure this will tell us that. Same idea, n and n minus 1 are based on the term in the sequence. So quickly we'll move on to an example. So show that the sequence is geometric. So we have 16, 8, 4, 2, 1. So I take the second term divided by the first one. 8 divided by 16 equals 1/2. Then I take the next two. 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. And 1 divided by 2 is 1/2. So, geometric sequence. Sequence, not sequences, where r equals 1/2. Now, find the general term. un equals I'm losing my mind, haven't done these in a while. Let me go back quick, look at this. We want u1 times r n minus 1. Perfect. Well, u1, first term of the sequence, r equals 1/2. So un equals 16 bracket 1/2 to the n minus 1. And that's all there is to figuring out a geometric sequence. Pretty straightforward. It goes back to our exponential graphs that we were working on before. So now, they give us k minus 1, k plus 2, and 3k are consecutive terms in a geometric sequence. Find k. So, what this means is r is equal to k plus 2 divided by k minus 1. R is also equal to 3k divided by k plus 2. Because they are consecutive terms in the sequence, that is how one of those things that we know. But we have to solve for k. Well, r is equal to this, and r is equal to this. We'll make them equal to each other. Moving this up a bit, sorry, a little too far. So that means k plus 2 over k minus 1 equals 3k, k plus 2. Now, unfortunately, I know some of you don't like this, but I'm going to use the term cross multiply. But what that's going to give me, k plus 2 times k plus 2 is equal to 3k, k minus. Now, that gives me, what do we got? K squared plus 4k plus 4 equals 3k squared minus 3k. Well, to solve for k, we got to make this equal to 0 because it is a quadratic. So I'm going to bring everything over to the right side. And that's going to give me 0 equals 2k squared, negative 3 minus 4, negative 7k minus 4. So a little work on the side over here, and I have this, what times what equals negative 8. What plus what equals negative 7. Well, if I have negative 8 times positive 1 gives me negative 8. Negative 8 plus 1 is negative 7. Unfortunately, because of this 2, we had to do the product that way, and we also have to do decomp. So 0 equals 2k squared minus 8k plus 1k minus 4. Factor the first two, I get 2k, k minus 4, plus 1, k minus 4. 0 now equals 2k plus 1, or times k minus 4. So k equals negative 1/2, or k equals 4. So what does that do for us way up here? K minus 1, k plus 2, and 3k are consecutive terms of a geometric sequence. Find k. Wow. So what are our options? We have sequential k minus 1, k plus 2, 3k. What do we have to do? Do we have to come up with find k? So we have two possible values for k. K equals negative 1/2, or k equals 4. And you can sub them in to create that, see if it works, and you'll find that both of those are possible answers to the problem. Now, one problem I don't think I added, or did I? Yep, here it is, one more. Geometric sequence has u2 equals negative 5, u5 equals 40. Well, un equals u1 r power n minus 1. So u2, which equals negative 5, so we'll do u2 over here, negative 5 equals u1 times r to the power 1. Beauty. That makes life a little easier. Now the next term, u5, u is 40, so 40 equals u1 times r to the power 4. u1 equals negative 5 over r. u1 equals 40 over r to the power 4. What I would do now is make those equal to each other. So negative 5 over r equals 40 over r to the power 4. And that's going to give me negative 5 r to the power 4 equals 40 r. I'm going to divide both sides by negative 5. So r to the power 4 equals 8r. Divide by r. Divide by r. Divide by r. That gives me r to the power 3 equals 8. So r equals 2. Because 8 equals 2 to the power 3. So r equals 2. R equals 2. What does u1 equal? u1 is going to equal negative 5 over 2 from this. And is that going to work? Because if I sub that into the other one, r to the power of 4, 16, factor out the 8, I get 5 over 2. Why aren't both of those negative? I have a minor issue. What am I going to do here? We're going to have -2 for our answer, so that it will produce a negative answer. That'll work for that. -2 there will make our answer 5 over 2. Sub it in over here, and I will get 5 over 2. So there's U1. And hopefully that'll make sense. If not, maybe Miss Stone can help you out. We're done.